Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends at Lineage. With their new managed database service, you can launch a production-ready MySQL, Postgres, or MongoDB cluster in minutes, with automated backups, 40 gigabit connections from your application hosts, and high-throughput SSDs. Go to dataengineeringpodcast.com/Linode today and get a $100 credit to launch a database, create a Kubernetes cluster, or take advantage of all of their other services. And don't forget to thank them for their continued support of this show. You wake up to a Slack message from your CEO, who's upset because the company's revenue dashboard is broken. You're told to fix it before this morning's board meeting, which is just minutes away. Enter Metaplane, the industry's only self-serve data observability tool. In just a few clicks, you identify the issue's root cause, conduct an impact analysis, and save the day. Data leaders at Imperfect Foods, Drift, and Vendor love Metaplane because it helps them catch, investigate, and fix data quality issues before their stakeholders ever notice they exist. Setup takes 30 minutes. You can literally get up and running with Metaplane by the end of this podcast. Sign up for a free forever plan at dataengineeringpodcast.com/Metaplane or try out their most advanced features with a 14-day free trial. And if you mention the podcast, you get a free In Data We Trust World Tour t-shirt. Your host is Tobias Macey, and today I'm interviewing Martin Sahlen about his work on data lineage at Alvin and how it factors into the day-to-day work of data engineers. So Martin, can you start by introducing yourself?
Yeah, hey, thanks for having me. My name is Martin, co-founder and CTO in Alvin. Yeah, previously been involved in startups all my career, always been very technical, hands-on focus. So really excited to be here today and get into the weeds of data lineage and how we solve it in Alvin.
And do you remember how you first got started working in data?
I think the proper real exposure I had to data was in my previous company called Unicast, still alive and kicking. There we were very much dealing with large data sets around GPS and mobility data. Kind of my main role there was to evaluate and work with data ingestion. So evaluating data vendors, ingesting data, making sure it had the right quality. And this was quite important for us because we kind of pay the vendors based on certain metrics of the data. So, I was sitting there trying to figure out ways, how can we automate this data quality? How can I equip the business people with documents to go into a negotiation and, highball or lowball? So it was quite interesting. The company was based in New York and Oslo, so a lot around ad tech and media. So, big volumes and quite a lot of money involved. So you kind of got the sense that this tangible ROI. So the coolest things I did there was creating these Jupyter notebooks, automating templating them and kind of generating these PDFs for the salespeople. And I think it kind of got me into there's so much low-hanging fruits here in this data space that can be automated. I think everyone that's really involved know that you can't really automate everything. A lot goes into people, process, and culture, but there's so much that can be automated, and I think we just kind of scratched the surface of it. So well, kind of, going back into my background. So I think that's kind of where I cut my teeth in data. We were very early, actually, in Google Cloud, even before Spotify had this article where they were moving all of their stuff to GCP. We worked on App Engine, PubSub, BigQuery, quite in the early days, and had a lot of fun doing that. That's kind of the background I have in data, I would say. When the time is right, you take a leap and start your own company.
So in terms of the Alvin project, can you describe a bit about what it is that you're building there and why you decided that data lineage is the area that you wanted to spend your time and focus on?
I think when you start a company, you always have a strong conviction. And in many cases, that's based on your experiences in your own company and the pain points, right, that you have. I think immediately when we started, we had this very big focus on the analyst experience and how can we improve the lives of the data analysts and, data quality and their understanding of what they have to work with. But we quite quickly found that we probably were a bit too biased, and you talk to data people and you get this sense of respect that the domains are so different, the process is so different. So you need to have a lot of humility going into these conversations and kind of understanding, what are the pains to solve here? What are the jobs to be done? This is pretty relevant to Alvin's story because then we kind of took a step back and looked at picture, I guess, of the state of data in general. And what we found was it's a lot more pain in data engineering, I think, than for the analyst. Once we really kind of went down that rabbit hole, still just trying to work on a hypothesis level, talking to people, building prototypes, and kind of iterating forwards. I think it was sometime during 2020, mid 2020, when we started working on analyzing query logs for usage, actually. This was related to cost optimization and understanding what are the drivers of cost in the data warehouse on the table level, query level, user level. And once we started really digging into SQL parsing, which I can go on for a long time to talk about, we found that actually data lineage is a hugely interesting topic. I think from a technical perspective and a more conceptual, computer science, graph theory perspective, it's very interesting. But what we also kind of hypothesized was that lineage is actually a data set as any other data set, and it can have quality and other aspects and metrics of a data set, but it can also be the foundation to build very useful products that work on metadata and useful products that can solve real pains for data engineers and data analysts. I think that was when Alvin kind of started, I guess, in its current form. That's when me and my co-founder just said, okay, this is super hard. We need to just, hunker down, go into build mode and build MVP basically for the lineage. And I guess the SQL parser basically. Yeah, so we spent quite a lot of time in that phase. And now we're just in this stage where we're kind of coming a bit more out. And I think we feel that the product and the technology is good enough.
In terms of the kind of core utility and core value of data lineage, there are a lot of different ways that it's being used, represented, generated. And I'm wondering if you can talk to some of the elements of data lineage that you're specifically focused on addressing at Alvin and the kind of core workflows and use cases that you're aiming for.
I think it always makes sense to start a little bit, how we do it. I think that's interesting. So, there are other companies in the space that, are focused on legacy tools and systems. And with that, the intrinsic focus becomes a bit more enterprise data migrations and how to move from, Oracle or something in cloud. While we made a choice to, we want the lineage to be really plug and play and automated. So, just connect your service accounts or your credentials or API keys, whatever applies. And we automatically generate this lineage graph and we extend it, if you add another system, we automatically kind of connect all the dots. How we do it, it varies from system to system. But if you look at the data warehouse, like I said, we don't want to focus too much on legacy tools. We focus on the ones that have documented query logs where you can actually access all the statements that I've executed. So we use that to generate the lineage, and generating lineage is really about, going through all the SQL line by line, parse it, understand, at a table level, at a column level, what is being done, like what columns are feeding into what columns, what are the transformations, essentially, how do these change over time. To us, we kind of, going back, I said it's a data set. And when we talk about lineage, we have an angle that, the granularity and accuracy is super important. If you really want to drive, high impact and high value use cases, it's important that the data you base it on is very accurate. As in any other data set, if the data is bad, the actions you can do upon it are going to be bad as well. So the story of the parser, like I said, that can go on for days and days, but I think it's an interesting, journey to, dive a bit into. So when we started, it was very much like, okay, table level lineage is probably okay. So we started out with this SQL parse library in Python, which I'm sure, most of the listeners have some kind of, have dabbled with some hackathons or something like that. And we came pretty far with that. But this is, I think, is generally true for writing parsers in Python. And maybe it's an incendiary statement, but the performance is simply not good enough if you want to run it at scale. We found that, you get 1,200, 1,500 line SQL statement, which is not that uncommon if you have these bigger companies and more complex data environments. And then you'll have just 10, 15 seconds just tokenizing the string into these, tokens. And then you have to start processing, which, is horrible. So we did all of the optimizations we could. We had this like Python code that would take the Python parts that were performance critical, make them into C code and import them, like lots of these things. And we got, 200% increase in performance, but it still wasn't good enough. I think if your company is going to be based on Lineage as the core foundation of the product, you kind of need to think a bit differently than, just having a hackathon project. So that's when we said we need to just build our own grammar and build our own kind of from scratch. So I think a tool that a lot of people probably have some familiarity with is Antler that we are using. So we actually use Antler and Kotlin because Kotlin is a great language. It's like, what Java or what Scala should have been, I think many people say. So there it's, just defining the grammar. You have all of this generated Kotlin code or Java code. We also use, for certain parts for BigQuery, we use SQL as well. And by using this and combining all of this into it's a unified parsing framework. So it's kind of like using certain parsers for certain things, and then it all goes into this same big structure that we can then process later. And this is a pretty nice architecture because it's almost like you generate this abstract syntax tree for any type of query, and then we can process that later for lineage and usage and statistics on the queries.
One of the things that you brought up in terms of the question of performance, obviously, if you're providing this as a service, you want to make sure that you're able to process updates in a scalable fashion. But it also brings up the question of kind of latency concerns, where if I, as a data engineer, am building a new workflow where maybe I'm adding a new DBT model or I'm building a new Airflow task graph, and I want to make sure that my lineage is getting updated. I'm wondering if there are any kind of latency concerns around how fast people typically want to see those changes in lineage reflected after that, task graph is executed the first time, and some of the ways that latency issues can crop up if you have a lot of, particularly as the size of the team scales where multiple people are working in the data infrastructure and they need to know in a timely fashion if there are changes to the dependency graph or the downstream assets that are being generated from the piece that you're working on.
Generally, we would rely on just hourly fetching of the query logs. We haven't, received huge amount of kind of reports that's not enough, I guess. So I think it also depends a little bit on the systems you're talking about, which I think is an important distinction. So for certain integrations, we define them as real-time or batch-based. And, Snowflake and Redshift and BigQuery. Well, BigQuery, you actually have these Google Cloud audit logs where you can do pub/sub and send in real time. But for tools like Snowflake and Looker and Tableau and all of those, you kind of have to fetch the data, at some certain cadence because they don't support these use cases. But for Airflow and Spark, and Databricks that we support, the integration is more real time. So we basically have listeners and this instrumenting code that would send changes in basically real time. So, from our perspective, we obviously want things to be as real time as possible, but there are also intrinsic limitations in the systems that make this hard at times.
In terms of the ways that data lineage is incorporated into the ways that data engineers work, I'm wondering what are some of the kind of stages of the data lifecycle or stages of development where data engineers are typically looking, or even, kind of the maintenance aspect where data engineers and data platform engineers and other people who are interacting with those data assets are looking to the lineage graph to inform or direct the work that they're doing.
This is like an interesting question where you also, it can be a bit, not controversial, I guess, but our take on this is really that lineage, as again, it's just a data set and technology. And I think a lot of products or companies, like, you would default to just providing people with huge graph, like a sprawling diagram that is very hard to process mentally, even for people that know the data stack. So our thinking and our approach is really to try to be a bit more, what are the processes and what are the kind of use cases where Lineage can be useful and where it can provide more actionable insights than having to, look through an impossibly large graph. So something that we call testing or regression testing, other people might call it impact analysis. I think it's a use case that really has been resonating, where we have a UI where you can write, any SQL state, which I think is quite cool, because you could say that you want to look at a table or a column or something and click on it and say, like, what if I did some change to this, what would happen? And that's kind of, good. But we think, most people write SQL. So we have this more SQL-based testing where you can just write any statement that, if it's a create table as select, we would kind of, okay, what's the output schema of this select statement, and compare it to the current state of that table. And then you would look at the lineage and the usage and basically, say that, well, this is a potential destructive action that would affect these people that continually are, doing ad hoc queries on these tables or connected to these dashboards. So it's really like thinking about, like, would the data engineer want to go into, even though I think our UI is nice, would they want to go there, or would they just want to, write some SQL and, understand what this actually is, semantically will do?
In terms of the ways that you envision the role of data lineage in the work of those data engineers, how does that factor into the ways that you consider how to store and represent and expose the lineage graph that you're constructing in the Alvin system?
Our main vision, I guess, I kind of skipped that a little bit, and maybe also the problem that we're solving. So maybe we can just go a little bit back to that. I think, one interesting thing that we have observed when you started around, 2019, I guess. So, in data space, that's, age old, right? It's moving so fast and so many things happening. And I think what we see is that there's this huge proliferation of DBT, right? It's been there for a long time. I think a lot of people, it's been there for a long time, but still it's really accelerated now. And I think with that and with these changes, everyone is now able to, write their models. Everyone is able to, be a data engineer. But I think a bit of the problem that we see is that there's so much things happening. Like, there's so many tables, like what's useful, what's not useful. And it's a little bit like, I'm definitely not saying DBT is the problem or is kind of part of the problem, but it's like one of the reasons that the problem exists, because, you can't replace good process and good culture with just tools. I think, it's a lot easier to just create a lot of models and tables, but it's a lot harder to remove them or change them. Like, it's a little bit like, the dark side of the moon, that you have all of this data that is being created, but you have no insight into how it's being used and how it's being consumed. And I think that is really, the core pain of what we're solving. And it sounds a bit, maybe unclear. And I think it is, because there's so many problems that data engineers are facing. And so it's hard to sometimes pinpoint exactly, this one problem. And I think everyone can not one day is the same, right? It's not like you're solving the same problem every day. Then it would be easy and the problem would be solved. But I think it gets down to these classic problems of, what can we change? What change? How can we kind of move forward without breaking everything? And I think even more recently, cost has become quite a bigger topic. You talk to data teams a couple of years ago, and, if you ask them about cost, they would be like, no, it's not even a topic. I think now if you look at certain people on LinkedIn, that talk about Snowflake cost, Databricks cost, it's really kind of becoming a topic. And I think a good comparison to what we see, if you look at software engineering, 20 years ago, there was FTP servers and people were like, hey, I'm working on this file now, don't work on it. And there were all of these very processes you look at now and be like, wow, this is crazy. This is like Stone Age. Hope I don't offend anyone that still does FTP stuff. But actually a fun fact is that in ad tech and media, most of the data exchange is through FTP. But even though they had this real-time bidding and these super fast exchanges, most of the data is daily batches on FTP. So it's quite funny. But anyway, kind of, going off that tangent, that software engineering has, now in a state where there's all these toolings, there's, automated tests, there's CI/CD, and there's like an amazing possibility to really understand how your code behaves and acts in the wild, which is, hugely valuable because it allows you to move quickly and revert changes. If, latency is going up, okay, we can, revert the change and try to identify what the issue was. We're not saying that we're going to bring all of that to data engineering because that's like, a lot. But we definitely see our vision as being a company that can really help data engineers be more effective and be more efficient and have this tooling that just integrates smoothly with whatever they're doing. As, a lot of these tools like Datadog, for instance, I think is a very good example. CI/CD is also a good example of this.
RudderStack helps you build a customer data platform on your warehouse or data lake. Instead of trapping data in a black box, they enable you to easily collect customer data from the entire stack and build an identity graph on your warehouse, giving you full visibility and control. Their SDKs make event streaming from any app or website easy, and their state-of-the-art reverse ETL pipelines enable you to send enriched data to any cloud tool. Sign up for free, or just get the free t-shirt for being a listener of the Data Engineering Podcast at dataengineeringpodcast.com/rudder. In terms of the kind of modeling at the lineage graph layer, there's obviously the question of kind of what are the connections and what is the actual asset that you're referring to. But I guess what are some of the general sources and representations of information that you are incorporating into that graph to be able to facilitate the use cases of, debugging, the type of information that you need to be able to manage in the graph to make it useful?
Like I said, I'm kind of reiterating on this a lot, but like Lineage is this data set. I think an important thing to bring into this is the temporal aspect of Lineage. I think, you can't just whack everything, up there and assume it's going to be useful. So we really want to highlight the operational and temporal aspect of Lineage because, when something bad happens, for example, then you kind of want to understand more specifically what it was when it happened and kind of resolve in that way. So in our lineage graph, statement type, the time it ran, the user that executed it, and these things on the job level is quite important. So identifying, is this SQL statement something that has executed, many times in the future? We have this thing we call query fingerprinting, where look at a statement, you remove all the literals, you remove all the parameters, and you kind of find the structure, I guess, of the statement, and you look at this over time to kind of bring information like, okay, is this the lineage here, or there was a failed job? Is this something that should have happened based on the previous history, or is this just some ad hoc lineage, like some analysts just created a table to do some analysis and, it's not a problem. No, we're definitely not there yet. I think we have a lot of really interesting ideas for how to, take the lineage forward. We do also layer in this information, let's say, like from Airflow and DBT. So our integrations with Airflow and DBT, they go quite deep. So we fetched associations between DBT runs and Airflow DAG runs and task instances with the underlying query IDs from the data warehouses and the source system. So this means that on the lineage graph itself, you can look at, okay, how does this lineage look like purely from the query history perspective? Just, if it's Snowflake, just the Snowflake tables. But then you can also overlay, well, what does this lineage look like from the DBT perspective? And then also, if you have Airflow, then how would this lineage look from the Airflow perspective? So it's kind of the idea that, like, multiple people have multiple ideas of lineage, how it should look to them. And that's kind of what we want to cater to. And now I can't remember exactly the name of it, but there was this really interesting article the other day about the layers of lineage, of data lineage, which sometimes you read articles and you wish like, oh, I wish I wrote that, because it was very aligned with kind of our thinking really around lineage, that there's a business layer and there's a technical layer. So obviously we now are most focused on the technical layer and providing something more than just a visual interface, but also more operational aspect. When it comes to the other systems, we really we think the most value is in this cross-system lineage. So you connect Tableau and Looker and your data warehouse. And then what we do is we kind of go into the APIs and the metadata in those systems, and we look for the connections that are set up there. And then we go into, okay, what are the connections we have already from the warehouse? And then we kind of match those up. So this enables us to do this cross-system lineage, quite elegantly, because then you connect like the systems, within some minutes or some hours, depending on the amount of metadata and queries, the lineage is automatically generated.
Given the fact that you are trying to track lineage across different systems and you have to kind of pull and generate and process that lineage differently depending on what type of technology you're working with, and they might all have different kind of syntaxes, particularly when you get into the BI layers. And then there's also the aspect of, even if you start at the data warehouse, there are potentially other upstream sources of lineage where processing is being done, or there might be manual steps that people are doing that don't actually take place in the context of an Airflow or a Dagster, or don't necessarily get driven by dbt in the warehouse. And so I'm curious how you think about ensuring the completeness of the lineage graph and being able to account for any out-of-band operations, or even just communicating the importance of making sure that operations are, executed in that context so that you do have the complete lineage graph.
I think, on the first one, there's different syntaxes and different dialects, even within SQL. I think our advantage there is that, it's not like we built a data catalog and then, okay, we need to whack in data lineage there. It's been like a 1.5, 2 years project of building a very strong data lineage foundation, and then we built everything around that. So there's dedicated team working on just the parser, there's dedicated team working on the integrations. So I think that's kind of our DNA. That's what we really focus on. When it comes to, yes, there's definitely cases where there might be processes or things that are putting data into the warehouse that just can't be tracked for different reasons. In those cases, we do, of course, have the option to do manual lineage, so you can extend the lineage graph with those things. Yeah, that kind of works quite well. What we have seen is that companies seem to be quite willing to invest there, because at the end of the day, nothing's perfect, but if you can get 90%, it's a lot better than, having to do everything yourself.
In terms of the implementation of the Alvin platform, I'm wondering if you can talk through some of the design and technical considerations and kind of engineering questions that you had to iterate on as you went from, this is a project that I'm interested in exploring, to where you are now, where you actually have a product that is user-facing that people are starting to onboard onto.
That's a long story. I think, any company that goes through these phases of fundraising and growth will kind of have to deal with that. But I think, like I said, I'm kind of coming back to the parser. I think, has been and is a continuous work in progress, and really adding, to that, restructuring that, working on the data model, making sure that we kind of just always, stay on top of things, reading, the Google Cloud blogs, the Snowflake blogs, like all of these things. Are we staying on top of the latest feature? So that's it's just been, it hasn't changed as much as just being like a, continuous improvement. I think on the platform side, we definitely, I wholeheartedly believe that, boring technology is, great technology because you understand it. So, while a lot of people might think that we use, some graph database or whatnot, we actually rely mainly on just Postgres and OpenSearch, Elasticsearch, OpenSearch. There was this schism with AWS, and people probably know that story where Elasticsearch got a bit upset with Amazon, taking advantage of their technology and forked it. But it's basically, having a search index and a primary database, and Redis for some of the caching has been the core of the stack since the get-go. As we are moving along, seeing that, we are getting to the limits of table sizes on Postgres, you start to add partitioning and these things that you only heard about, and now you have to do them. So doing this live migrations have certainly been also interesting. I think we also really seen the value of, instrumentation and observability in when you're doing this syncing, you're grabbing data from potentially huge amounts of data from the client's data infrastructure. In those cases, it's quite important to be mindful that you are calling their APIs, and you might cause those systems to be slower if you don't do things correctly. So that's also something we had like a very big focus on, to just be really mindful of minimizing the amount of time spent on client connections and kind of getting the data and then processing it on our side. So I think it's, the story is a little bit, yes, boring in that sense, that I think, these things you have to scale and as you grow out engineering organization. The stack itself, runs on Kubernetes. We use Airflow to handle all the syncing needs. So I think we have built a pretty, I would say, like clever integration with Airflow and dynamic DAGs. So we're able to basically integrate Airflow quite nicely into our infrastructure using Kubernetes operator as well. So everything just runs in our cluster. And it also means that based on different needs, different client needs even, we can assign the syncing jobs to run on specific nodes that might have more memory or CPU depending on the specific needs or SLAs.
For data engineers who are onboarding onto Alvin, I know you mentioned focusing on data warehouses and some of the business intelligence layers, and I'm wondering how you think about the kind of initial product focus to be able to keep the problem scoped and addressable, and how you're thinking about the potential for expanding into some of the other types of systems and architectures that data engineers are going to be working in. So in terms of data warehouses versus data lakes, structured versus unstructured, kind of which BI tools you want to integrate with, which kind of orchestration engines, and just some of the ways that your implementation and architecture is designed to be able to allow for this expansion of scope and capabilities.
One of the bigger projects that we have on the roadmap for Q4 is to do like a bit of a refactor on the data layer to support more of these layers of data lineage, as I said. I think one of the really big advantages that we have had from the really early days of starting is that we just assigned the data model to be super simple, like, very almost stupidly simple, that there's data entities and there's connections between entities, like almost like, a textbook example of, graph, like nodes and edges. I think that has been a great advantage, because it has really allowed us to, when you approach an integration, we almost had this like methodology of, okay, we look at the system, we try to understand the semantics of the system. What's the data model here? How can we map that into our system? So, like so far, we have integrated with Airflow, Databricks, BigQuery, Spark, Mode, Looker, quite different systems, I would say, with different like metadata models and different concepts within those. But so far, we've been able to model those. Also quite, I think an important aspect also, you need to model the data so it's recognizable to the consumer, right? So like you need to, if it's Looker, there's folders and dashboards, then probably you should display the same folders and dashboards, or in Tableau, it's workbooks and sheets, yeah? So you need to give them that familiar experience, I guess. But so far that has been, we haven't had huge challenges there. And again, I think if you just try to stay simple and have this like, it's almost like if you have a canvas, then constraints, breed creativity, and it's almost easier to know that this is our data model, and then this is kind of what we need to fit it into. And so far that's been working pretty well.
As far as the way that Alvin integrates into the workflow of a data engineer, I'm wondering if it's something where the data engineer is going to the Alvin UI and exploring the data lineage and then jumping back into other tools, or how you're thinking about being able to integrate more closely into the places that the work is being done and being able to surface that information in a more seamless and frictionless way.
That's also a topic that is, very of great interest to me, and where I think maybe it's a little tangent to kind of go on, but there's too much like inward focus, I think, in a lot of the companies that are trying to enter the space and are trying to be category defining in some way. And a lot of that is probably fueled by investors that, to be category defining, and then everyone's kind of fighting a little bit to do that. We're probably guilty of that as well. I'm probably throwing stones in a glass house, but still, I think it's important, like I said, to stay humble and try to be focused on the use cases and the processes of the data engineers. So I think our approach is really to latch onto whatever they're using, and DBT is an obvious one there when it comes to just market reach and ability to provide value to many data engineers. So what we have there is we have this impact analysis or regression testing, as we also like to call it. But the thinking there is that a lot of companies already use GitHub or GitLab Actions to run data quality tests, basically data quality tests on changes that they're making. What we see there is that this is like a perfect area to also integrate our tooling, because what we provide there, like you have data quality tests, which everyone would argue they're super useful. You can look at the column distribution changes and understand a bit more what suddenly you get like zero values where you should expect to have an even distribution. But like our really, I guess, thinking is that the biggest problem, at least we see with data engineers, is not what happens within the data warehouse. It's a little bit more who is going to ping them on Slack, or how do you communicate these changes. If you look at what we do cross system lineage and usage. So that means that you kind of understand who is looking at this dashboard, who is consuming or who is reading from this table. Then when you kind of have a lineage graph that is so accurate that you can say what's write usage, what's read usage, you do pretty interesting stuff. So what we have on the DBT side is something that can comment back on the pull request and give you a report of, okay, these are all the downstream users of these tables that you're now changing. And, if it's a BI user or if it's just an analyst. And then you can kind of exclude all the pipeline queries, all the queries that are just creating tables based on this asset, but just actual people in the company that are consuming this. I think this, can of course also be, viewed in Alvin's UI and all of that. But, our real product vision is to, just be useful in that context and almost be seen as something you have to do as part of your engineering workflows to run this test. Then you could also, say that, well, we're going to do these changes and we're going to break these things, but then you also have a list of people that you can warn of these things. And I think that's almost equally important, because you talk to especially heads of data and data team leads, like a lot of them are really, passionate and motivated and have a lot of, pride in the sense that we want to drive change and we want to make sure that the company can be data driven. And it's not great for them if someone asks them like, hey, what's wrong here? If something is wrong, if they can communicate it first, that's also like a big win for them. And something that, just from a company perspective matters a lot to them.
Data teams are increasingly under pressure to deliver. According to a recent survey by Ascend.io, 95% reported being at or over capacity. With 72% of data experts reporting demands on their team going up faster than they can hire, it's no surprise they are increasingly turning to automation. In fact, while only 3.5% report having current investments in automation, 85% of data teams plan on investing in automation in the next 12 months. That's where our friends at Ascend.io come in. The Ascend Data Automation Cloud provides a unified platform for data ingestion, transformation, orchestration, and observability. Ascend users love its declarative pipelines, powerful SDK, elegant UI, and extensible plugin architecture, as well as its support for Python, SQL, Scala, and Java. Ascend automates workloads on Snowflake, Databricks, BigQuery, and open source Spark, and can be deployed in AWS, Azure, or GCP. Go to dataengineeringpodcast.com/ascend and sign up for a free trial. If you're a Data Engineering Podcast listener, you get credits worth $5,000 when you become a customer. The other interesting aspect of data lineage is that it is a collaborative element where it does allow data engineers to understand what is the impact I'm going to have if I change this table, or, why is this report not rendering properly? I can look upstream to see what happened, or what are the nodes that feed into this, and maybe see what are the changes that occurred in that. And I'm wondering, from the data consumer perspective, how you also think about that kind of collaboration aspect, and how you're thinking about building Alvin to be this cross-cutting view of what is happening in the data system and being able to surface the information that each of those different stakeholders cares about at their point of access.
We do have obviously features. I mean, we do have a data catalog as well, and we do have features there that allow you to assign basic governance, like you can tag things with types tag, like schematic tagging, so you can say this tag should be a person or this tag should be a number, so you can basically do a lot, set SLAs, set ownership, these kind of things, and then when you combine that with Lineage, you have some really interesting things you can do with that to say, like, maybe someone should be warned if something happens and these types of things. That's a little bit, I guess, more bread and butter. One thing that we recently put out in the product is what we called views. I think that's really where it gets interesting, because we have all this usage data that we basically model in a way so you can just slice and dice it. So as a business user, you can set up a search basically, or a view into all the assets, all the dashboards that match a certain name, or all the dashboards in a certain Looker folder. As a data engineer, you can look at all the Airflow kind of pipelines. And essentially the thinking is that I think as a tool, especially for that, aims to be used widely, at least over time, I think it's like you really have to thread that line of being opinionated about how the tool should be used versus allowing flexibility to the end user. And, I'm not saying we have nailed that at all. I don't think we have, but we've really seen some good feedback on this idea that, here you can just create your own curated views into the metadata. And if you look at collaboration, onboarding, you can do basic things like, this is a view of all the tables that are tagged with gold or silver, standard. These are all the tables that belong to a certain team. And then, a lot of companies don't even have these things, just onboarding is a little bit like just, hey, look at the DBT graph. And then, it was 800 models there. So, and I have no idea what's used or not, where I start here.
And to that point of usage and understanding what is active versus what is stale or what was created as a one-off, how do you capture some of that information and think about how to surface that at a glance when somebody's looking at the graph, where they can say, okay, here are the 800 DBT models. I can see that, this model at the end of this graph is actually used by this BI dashboard that's accessed 5 times a day, versus this other DBT model was generated and doesn't have any other connections, or maybe it does have a connection to a dashboard, but that dashboard was looked at one time 8 months ago. And being able to use that to understand, okay, I can safely prune these models because they're not being used or they're not generating value, versus if I prune this model, then everything is going to break.
I think those exact questions are, the core of why we, have built and are building Alvin. I think, we sat there and discussed on, like, these are the questions that we want to be able to answer. I think, we're on the UI side. It's probably like a little bit, more kind of elbow grease to get there. But we basically have all this data. And I think more, if you look at a technical perspective, which, the UI part is just, the final, mile of the marathon where you can, build this nice cherries on top. But the really hard engineering work has all been done. And I think that's, you can, pruning, I think, is a really interesting concept, because if you look at a huge pipeline or a huge DBT DAG, you can look at, if you would only analyze, at the rudimentary level, you could say that, well, all of these tables are being used, every day because the entire DAG is materialized every day. But then if you look even closer, you can see that, well, all the queries are just, create a select or, some kind of derivative of that. So they are actually all write queries and there's nothing else happening. And that's kind of can reveal, huge opportunities for pruning data and thus saving costs. So for things like BigQuery, where, the cost $5 per terabyte scan, like, you actually have a cost. So you can actually, in those cases, you can give, well, this is actually, the hard cash you would save by just pruning those. And that's perfectly fine, because there's one dashboard connected to this model, but it was last viewed, a month ago. So it's probably okay. Equally, we can also do, these things with Airflow. You can, by associating the task instances of a DAG run with the queries they're running, you can kind of do similar. So you can say, hey, this Airflow DAG is costing you a lot of money, but these tasks, they don't really have any impact. You should just drop them.
As far as the overall space of data lineage and the areas that you've been able to dig into and problems you've been able to surface in the process of building Alvin and working with some of your early customers, what do you see as some of the open questions and areas for investigation and further improvement in the space of data lineage, whether that's the kind of technical implementation of how you construct and represent the lineage graph, or the applications and use cases for lineage, or the opportunities that for building on top of lineage to add extra kind of automation capabilities, but just kind of like from this view of data lineage as a problem space, what are the things that are not being addressed or leveraged as fully as they could be?
I think the general kind of problem is a little bit, as you also wrote in one of the questions, that it's a little bit, overused. The term is like, almost losing its meaning a little bit. I think, we need to, as an industry, we need to like give value back to it. And I think how we do that is, it's no different to what I've been, trying to preach, or we're still trying to preach, that you need to show like how it can be used and why it's useful. I think what we as an industry have, a long way to go. I think Lineage is unfortunately a little bit, just put in a corner as, a feature that, someone ticks a checkbox and okay, there's a diagram there, then great, we have Lineage. So I think really focusing on that is how it can be used and how it is useful, and really how it can drive value, save time, increase quality, I think is, it's like a pillar of, data observability. I think I can talk like so much about this as a topic, but I also think it's, at least what we see, it's also on the buyer side, I guess, it's also like, I guess it's because there has been so much funding into the space, so much investment. Everyone's saying that, yeah, we have column level lineage, we have everything. It has kind of set the expectations so high that, you read a proof of concept or an RFP from a company, and they expect to have absolutely everything, and I think that's probably not feasible from one single product. So I think at the state of the industry at the moment is also a little bit, yeah, like you can definitely see there's a bit of like antithesis about talking about cost and the kind of the problematic sides of DBT. So yeah, I think it's at the end of the day, the conclusion of this kind of long rant is it's about showing value and pointing to what's the tangible benefits of having this, not just talking about it as a technology.
In your work of building Alvin and working with some of your early customers and design partners, what are some of the most interesting or innovative or unexpected ways that you've seen Alvin used?
It's really more, I would say, not to kind of pat our own backs, I guess, but it's a little bit more how well we have been able to integrate it, and how much effort you kind of have put into making something that just runs in whatever Airflow version, or just have something that just works. I think that's kind of the thing. The use cases are usually pretty well scoped out. Like you want to achieve certain outcomes. The features are pretty scoped towards that. So I don't know if I maybe it's a boring answer, but to us, a day where we're able to have a client just not do anything and achieve the results they want, that's kind of the the holy grail for us, that there is this plug and play magic to the Lineage. So I'm sorry, it's hard to answer that in this like very exciting way, I think.
No, I mean, in a lot of ways, particularly when you're working at the foundational layers of a stack that is intended to drive potentially massive amounts of value, boring is what you're aiming for.
Yeah, like a boring day is a good day, right?
Exactly. Excitement usually means that something went wrong.
Yeah, exactly.
And in your work of building the technology and building the business around Alvin, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I think, again, like when you work on a really foundational layer, I think you are a lot more vulnerable to, the basics of computer science, big O notation and those things. I think these are really the things you have to think about, that, memory usage and, design things that, scale well. And I think this has been very challenging for us, because you do something that works in your own environment and you kind of you're running it and it works smoothly, and then you're onboarding some clients and everything just blows up. You just have to do kind of real firefighting. So I think like when you work in an environment where what you get in is so unpredictable, like you almost have to be, ready for everything in terms of how companies are using it, like what they're doing. Like at one point, it's completely unpredictable, right? So at one point you had like one company that was like 90% of all the data that we had because they did things in, some way. So I think this unpredictability has been very challenging to solve in a good way when you want to provide a product that meets very, very, strict requirements on, timeliness and correctness of the data. So, it's not like you're just building a web app. It's quite many components. So again, like a bit of a boring answer, but like I said, when you're working on this low level, it's usually this more low level kind of problems that you have to deal with.
For people who are interested in being able to build and take advantage of the Lineage graph for their own data platform and data assets, what are the cases where Alvin is the wrong choice?
I think it depends a little bit on, maturity, kind of where you're at in your journey. I think we talked to a lot of companies where you realize that a lot of this is more about culture and kind of people and seeing that you can kind of drive the change. So I think it's a little bit, you have to be kind of ready to embrace this, from a company perspective. That being said, I think, technically, we also talk to companies that are investing heavily in their own tooling and have like really, really, talented people doing that. If that's priority and if that's an investment that the company is willing to make, and some, make their own kind of internal DBT like tooling where they use annotation and metadata-driven pipelines where they kind of have all of this information, in terms of lineage and whatnot, then, that's a hard sell with what we do. So I think that's specific. But all in all, I think if you're using, DBT or you're not using DBT, but you still want to get the lineage, I think Alvin is the right choice.
As you continue to build and scale the Alvin product and start to onboard more customers and open it up for general availability, what are some of the things you have planned for the near to medium term, or projects or new capabilities you're excited to dig into?
Yeah, like I alluded a little bit to, the Q4 for us will be exciting. I think there's a couple of bigger roadmap items. One is the, layering lineage more in the sense of being able to like show, the different, what are the, based on the lineage data, what are the pipelines, what's the technical lineage, what's the more like, business lineage, and really being able to show that in a good way. So that's an important one. Then another thing that we, just are dipping our toes a bit into is what I would call more a semantic logging and alerting. So based on the query logs, you have a lot of information that's interesting. You can use it to, let's say, version metadata. So you have these create or replace statements. You can kind of say like, this temporal aspect of, let's say, a table. It's almost like you can create, a git commit log for the data warehouse based on the statement. Again, these are, foundational things that can be used to do really interesting stuff, such as logging and alerting. So I think once you're talking about logging and alerting, like you're also talking a bit about observability. But I think it's a little bit in our, DNA that we, maybe we don't always move the fastest, but we really believe in, thinking a bit about the foundations of what you're trying to achieve. And then, that allows you to move really fast once you have that. And that's something we have seen with the lineage is that like, you have like a really good foundation for lineage and impact analysis, usage, like all of those things you can build and ship very, very quickly because you don't have to, hack or retrofit because you have this like good foundation.
Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
The biggest gap, I think, is, it's still so nascent. And, I think the focus, for instance, on there's like a huge focus on data observability, for instance. But why aren't we talking about data actionability? Like, I think there's this obsession with specific concepts or ideas, but there's like a big gap of actually making this valuable and useful. And that to me, that's like a huge chasm. This, there's a lot of talking and conversation, but there's a big gap of how do we take this and actually make it valuable and useful for data engineers. And, that's what we in Alvin really hope to fix.
All right. Well, thank you very much for taking the time today to join me and share the work that you're doing at Alvin and your overall explorations and thoughts on the data lineage space. It's definitely a very interesting and important problem area. So I appreciate all of the time and energy that you and your team are putting into making it a more tractable and accessible problem area for people who want to take advantage of its capabilities. So appreciate all the time and energy you're putting into that. And I hope you enjoy the rest of your day.
Thanks a lot. Have a great day too.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.